Hello once again. Welcome to again another series of the BMW series, and I thought this was a diagram that's pretty easy to understand off of the Chilton books that they have. As you can see over here, these are the symbols of the components, and we went over these in a couple of videos, so I'm just going to give you a glimpse of it if you're having difficulty remembering these symbols. Obviously, these are used the most: the fuse, the circuit breaker, a fuse link, a ground over here. As you can see, a capacitor, we'll deal with that. So, a normally open switch. So, now you can see them, again, the symbols, if you're having problems remembering them. And a heating element for oxygen sensor. Now let's go to the actual schematic. Okay, this schematic is helpful because it labels each component and identifies it. So this is the blueprint for all schematics, regardless of automotive type, Asian, European, domestic, doesn't matter. So as you can see over here, it tells you this dot over here is a splice, is a connection. Over here, there is no dot. That means this one over here is not connected to this one over here. This dot over here means this is connected here, and it's connected to this one. Okay, now, power conditions, when it says hot at all times, or it says hot and run or start, hot and run or start, this is the ignition switch, hot and run or start, that means either this one. Hot at all times means it doesn't matter where this switch is, in or out of the ignition switch, you'll still have voltage regardless of where the switch is in any condition. It's always going to be hot at all times. This is necessarily specifically in the run position or in the start position. Now, a case ground. This is called a capacitor. A splice, like we just specified, this is a splice, or I call it a node. It's a connection. Now, this is a capacitor. Component names, see the component names, spark plugs, spark plugs, spark plugs. A case ground. A PCM power relay. It even tells you what the symbol is: a relay, a capacitor. And it tells you fuel injector. Some schematics, old types, they wouldn't even label this. They wouldn't even tell you this is a relay. They wouldn't even tell you this is a capacitor. You have to know the symbols themselves. So, pretty lucky that it does specify what they are. Anyway, capacitor. What's a capacitor? Capacitor has a few purposes. In this case over here, one goes to 12 volts. See the 12 volts here? It'll have 12 volts. Another will be grounded. A capacitor could be a low-pass filter. It could be a high-pass filter. It could be a block DC, which it does, and allow AC. In this purpose over here, since one side goes to ground, other goes to 12 volt, it's like it's storing a charge, like a battery. So it'll store a charge at 12 volts. Now, ever notice when you turn off the ignition key? You turn off the ignition key, what happens? Sometimes the radio, the accessories, the dashboard are still on. But you just close the ignition switch. That means there should be no power going to anything. What gives that power? Capacitor gives that power. While you switch off this to 12 volts, the capacitor is holding a charge and it's discharging. However, if you ever see the radio is on, the clock is always on. From the battery, it's always on. But the radio itself is on sometimes, and other accessories. The capacitor is providing the charge for those accessories after you turn off the switch. Now, you ever see sometimes after like 15 minutes, 20 minutes, then your radio goes off. Why? Because the capacitor is slowly discharging the charge it has on it through another component through ground. In this case, it's going through this coil to ground. So it's discharging the charge through this coil of the relay to ground. It might take 15 minutes, it might take 20 minutes, depending on the resistance of this relay. So you turn off the key, and the radio is still on. You say, why is the radio still on? Why is some accessories still on? Well, the capacitor is on. If you want to discharge it quickly, what do? You open the door. When you open the door, boom, a discharge right to ground through a switch, and the capacitor loses its charge, accessories go off. If you ever wondered why that happens. Now, let's get to some more important things. Okay, over here, wire color abbreviate. If you're not sure of the colors of these wiring, right? Right over here it says R, a dash, and LG. So R, we look up R. R is red. LG, right? LG, we look over here for the abbreviation LG, and we find light green. Light green. So therefore, this is red with a light green stripe. And that's how you use this table whenever you need to know what these are abbreviated. Red, light green. Okay? So remember this. So usually they're the same for most models. Sometimes they're not, but you always have a table, or a truth table I call it, to tell you what these are standing for. So now you know when you see R, red. Okay? And usually every schematic they tell you the color of the wire. Okay? Now, grounds, these are physical grounds. The computer does not give you a ground. This is a physical ground. This, when it labels this, AC and heating, this is where these are going to. These wires are going to. So in other words, blue, yellow, okay, is going to air conditioning and heating systems. Sometimes they might have a triangle with the letter A or B or C. That means that's a continuation on another page. After all, these diagrams could be 30, 40 pages long for automotive. The terminal numbers, the pins themselves, you see these numbers, 92, 29, 53. These are the terminal numbers of this module, computer module called the powertrain control module. We know it's abbreviated as PCM for short. So therefore, these are the pin numbers. So therefore, if you want 49, if I ask you what's pin 49 on the PCM, your answer should be, it goes to the ignition control module to pin 1. If I ask you what's pin 25, I believe it's 25, your answer should be, goes to pin 4 of what? Ignition control module. If I ask you what's pin 50, your answer should be spark output check connector, going to where? Or coming from where? Ignition control module, which pin? I believe that's 5. Pin 5. So anyway, that's how you go about it. Okay? So, you know what this is, the wire color. You know what this is. You know what this is. Now we can start analyzing. So, here's a relay. And this is why I picked it. This is for BMW, but so is the case, the scenario for most vehicles. Relays are abundant, and they are all over. That's the first thing that you think of when you have an electrical problem, is the relay activated. And how do I go about troubleshooting it? What's the first part we always talk about that has to be activated? This side, the coil side. So it always comes from a fuse. Now the question was asked to me from a viewer. Does it make a difference of the fuse rating that I will lose 12 volts or 0 volts? Does it make a difference? Because I always say 12 volts on one side, 12 volts after the fuse. That means how much did I lose across the fuse? 0 volts. Does it make a difference if it's 30 amp fuse? Does it make a difference if it's 15 amp? No. This is a short circuit. This conductor has 0 ohms, very close to 0 ohms. Oh, how do I get that? Ohm's law. I don't want to get too deep. Ohm's law tells us if there's 0 ohms or close to it, you could have a 0 volt drop across that component. Therefore, if there's 12 volts here, 12 volts over here across a 30 amp. If there's 12 volts here, 12 over here across a 15 amp, a 10 amp, a 5 amp, a 2 amp, doesn't matter. Ohm's law gives us the right to analyze it that way. Okay? Now, here we go over here. This is the first one. When I use schematics arrows, this is not voltage flow. This is current flow. So someone was asking me, voltage does not flow. Voltage is a pressure, a force that pushes electrons, current, to flow. So whenever you see arrows in this direction, that means the current flow is going this way. There is electron flow. There's an argument, positive, negative, it doesn't matter. What's important is that current does flow, not the direction. Okay, so current flows from here, from the battery. In which position? in a run or start position through what amp fuse? Through a 15 amp fuse. Going through here. Is there a connection here? Yes, there is. They're connected here also. We go through a coil and a resistor in parallel with it to a ground, a physical ground. Great. Now, 12 volts over here. And if this is ground, how much should be the voltage? 0 volts, always. Always 0 volts if you're connected to ground. That gives us the right for this contact to close. This contact that was normally open will be now in this position. In the closed position. Now, where are we connected to? In this position, are we connected to fuse number, I guess S, whatever that is, the 30 amp fuse? Yes, we are. So 12 volts. How much should I have here? I should always have 12 volts here, regardless if this is open or this is closed. If I would put my meter here, I should get 12 volts. Why? Because I'm always connected to B+. Always, regardless of him. Because this is before the contact in the relay. After the contact, this is called after the contacts are closed. This is called after the relay, the coil. This is called before. This is called before. So after this, now we have how much here? 12 volts. I'm connected to where? The battery. Through what? Through the contact switch and through, this is called the load side, through the fuse. 12 volts here all over. Now, again, you have a problem with the no start. You can't start the car. You have a communications problem. You think it's the PCM. After doing a video from yesterday, where's the first place that we look? Okay? Now, let's say your friend comes to you and you say, "Oh, I had a hard time yesterday morning starting the car," right? Change the starter motor, change the battery, change all wirings, all corrosion I did, right? What's your first response after he tells you all that data and all that money that he put into that car? What's your first response for watching these videos? You should ask him, what about the computer module? Did you check the computer module? Or did you change the computer module? And he'll say, I didn't even think of that a car has a computer module. As we know from watching these videos, sure enough is the case. The power control module feeds where? The fuel injectors. Otherwise, you don't get fuel. You can have pressure, but if the fuel injectors don't come on, you're not getting fuel into the cylinders. So now, and you're not going to get spark. Now, we find where is the main point going to 12 volts. If we come over here, hot at all times, this fuse will always have 12 volts. So let's draw it in. One side. After the fuse, how much should I have? 12 volts. Does it make a difference if it's 15 amps or 30 amps? No. So if I have 12 volts here, 12 volts over here, how much voltage did I lose across this? 0 volts. Now, the flow is through here, the current flow, and guess where we are? So we landed at pin, what? 55 of the PCM control module, getting 12 volts. So what's the main feed line? The main feed line is pin 55, if I ask you. Make sure that this gets 12 volts. Why do we need 12 volts? Because remember, this gives grounds. This has to be activated. For this to be activated to give ground to the fuel injectors, he has to get his main feed of 12 volts first. Now the question is there only one line of 12 volts? Or can there be many? The answer is there can be many. Can there be one power relay? Or can there be many? There can be many. Can there be one fuel pump relay? Or can there be many? There can be many. That's where you get the wiring diagram. So we came over here, we said 12 volts. So I just came out with a theory. This is 12 volts going to where? The fuel injectors. This is another 12 volts going to where? The ignition control module. Which pin? The 8. What wire? What color? Red. You see this one? And it actually spelled it out for you. It said RED. Over here it says RRR. This one is spelled it out. Doesn't make a difference as long as you know the color of the wiring. Now, so everything needs 12 volts. So if I come over here and I measure 12 volts to pin 55, but then I say, wait a second, no fuel, nothing. What's going on here? The PCM is getting the 12 volts. What am I missing here, right? You're going to say, well, does the computer give a ground first to the relay, or is it a physical ground? Your answer should be a physical ground. This is a physical ground, right? Therefore, 12 volts is needed after this is activated. Then all the fuel injectors, this ignition control module is activated. That's the main point. That's why you see, whenever you see PCM power relay, right? Remember, that means it activates something in the PCM. Okay? It activates this, but also, look at this, 12 volts here, 12 volts over here. This will be 12 volts, this will be 12 volts. This is a connection, this is a splice. Remember we said that? So how much should I have at pin 97 and pin 71? I should have 12 volts. 1 pin, 12 volts. 2 pin, 12 volts. 3 pins so far of 12 volts. Now remember, this powertrain control module can have 200 pins. You're not going to see all 200 pins here. You're going to see whatever the highest one here. I don't even know what it is, 96, but we skip pins. Why? Because the other pins have nothing to do with the system. It goes to a different system. So it's not going to show you all 97 pins. It's only going to show you the pins that's associated with fuel injectors, mass airflow sensor, ignition control module. Okay? Remember that. So now we have 3 points of 12 volts. Oh boy, right? Now, it needs just 12 volts here. I have to check this one. I have to check this one. I have to check this one. Of course, how difficult is it to check it unless you have back probes and things like that? So 12 volts here, and then the fuel injectors go here. How much is it? This is a splice. There's a connection here, a connection here, a connection. So how much of these will get 12 volts? Is he going to get 12 volts? Is he going to get 12 volts? Yesterday, I made a video about a common bus line. Whenever you see all these nodes, these splices, one thing should go into your head. This is a voltage supply line. 12 volts here, 12 volts here, 12 volts here, 12 volts to each and every single fuel injector. 12 volts also to the ignition control module to give you the spark. This gives you the fuel out of the fuel injector. This gives you the ignition coil to give you the spark. Okay? Very important. Mass airflow sensor. What gives you the 12 volts for the mass airflow sensor? Right here. This is the connection. A splice. We come over here. Follow the arrow. We come over 12 volts. Now, mass airflow sensor. When it comes, there's always a question is, do you get aftermarket? Do you go to the dealer? What do you do? When it comes to air-fuel ratio determined by the computer, you see this is an input to the computer. I express one thing. Always try to get the part from the dealer. Why? Because this has to be precise. In order for this to be precise, this electronic component has to be correct. Okay? Remember, the powertrain control module looks at 0.01 volt, 0.02 volts, 0.03 volts, 0.05, and so on and so on. It doesn't. You cannot say that 0.1. If I measured 0.5, and it's supposed to be 0.9, oh, that's close enough. That's close enough. No, not for the computer. The computer looks at 100th of a volt to determine the correct information and data it gets it from, which are programmed and stored in memory and a microprocessor, and then it goes and uses that information to increase or decrease fuel where? In the fuel injectors. This has to be precise. That's why I always stress, unless you have a car that's, let's say, 300,000 miles and has many problems, why go to the dealer to spend so much money when you have so many problems with a car with so much mileage? That doesn't make sense either, right? You go to the junkyard, get a cheap part, ask them, look, you have a BMW, whatever, 350 series, whatever it is, I need a mass airflow sensor. Of course, it'll be cheap, but hey, why invest in such a high mileage car to go to the dealership? My example is when you have low mileage on a car, and to avoid problems, avoid changing this 2 or 3 times until finally you get to the conclusion, hey, I should go to the dealership, whatever. Listen, when it comes to electronics, any sensor, whatever it is, I always stress go to that for that reason. This is, the computer looks at it and that information. I'll make another video. Please go to my channel, Joe Electronic Schematic for Auto. My other one, Automotive Electronic Schematics by Joseph. I need 6,000 minutes for that one. Getting close for that one. And I'm going to go to another with BMW, another schematic. These are very tough schematics for BMW. They're in a class of their own.